Hello, it's me, Oscar from Marijuana Garden.
This situation with Starlink satellites highlights a critical challenge at the intersection of space weather and modern mega-constellations. We are currently in the peak of the sun's 11-year activity cycle. This means frequent geomagnetic storms and, coronal mass ejections, CMEs. Intense solar energy heats Earth's upper atmosphere, the thermosphere and exosphere, causing it to expand significantly. Satellites in low Earth orbit like Starlink, which typically fly between 300 and 600 kilometers up, travel through this denser atmosphere. This increased density creates much higher atmospheric drag, acting kind of like a brake on the satellites. The increased drag saps orbital energy, causing satellites to slow down and, spiral closer to Earth much faster than during solar minimum. NASA research, specifically from Oliveira and colleagues, confirms this directly correlates with the premature re-entry of hundreds of Starlink satellites since 2020. Satellites that were supposed to last for years are, burning up after just a few months or even days in some extreme situations. SpaceX now has to launch replacement satellites way more often just to keep the constellation up and running, which really ramps up both costs and the pressure to launch more frequently. Plus, this unpredictable and rapid decay just makes it so much harder for everyone up there to manage space traffic, avoid collisions, and plan for debris mitigation in low Earth orbit. So, Starlink has actually lost thousands of satellites in total, and solar activity is a big reason behind the recent spike in those numbers. Even though these satellites are supposed to burn up completely, the sheer number of them means a lot of metals, especially aluminum, are getting dumped into the upper atmosphere, which could have long-term effects on things like the ozone layer and even how bright the night sky is. And while most of the satellites do disintegrate, there's still a small chance that bigger pieces could survive and add to the risk calculations for everyone. This is honestly the very first solar maximum where we've had thousands of commercial satellites packed tightly into low Earth orbit. It's basically a huge stress test for mega constellations, showing just how vulnerable they are to space weather. The data we're collecting now is, super valuable for understanding how solar activity really impacts these large satellite fleets, and it'll help us make better designs and smarter operational decisions in the future. So, in essence, solar maximum is kind of acting like a giant atmospheric brake pedal in low Earth orbit. Because Starlink operates at such a low altitude, it's especially exposed to this increased drag, which is causing satellites to fail earlier than expected. That means SpaceX is dealing with a lot of operational headaches, there are some real environmental concerns, and the whole space industry is learning some pretty important lessons about the risks of running huge constellations during periods of high solar activity. At this point, things like raising orbits during solar max, beefing up propulsion systems, or just having better atmospheric models are, honestly, becoming essential strategies.